We are more or less ready to start this webinar. So first of all, welcome to CSA webinar. Today, the topic is Allas and Geospatial data. Myself, I'm Johannes Nyman. I'm working as a GIS specialist at CSC. And yeah, let's get to it. So first of all, this webinar will be recorded and it will be published in the CSC YouTube channel. So beware of that. If you have any questions, please write them down in the chat window. I will be looking at it in some intervals and answering your questions as well. Hopefully we'll have some time in the end as well for questions and answers maybe too. This webinar is about Allas and Geospatial data. So the focus today is about maybe GIS. So if you're looking about information or basic information of Allas, how to use it and what it is and so on, I suggest you look the previous webinars held by Kimmo Mattila, and there's a link as well in the slides. And by the way, the slides are available to download, so you can follow this presentation from your own computer as well. And it may be even, I can even recommend it as I have some code here, so you'll be able to follow when I write stuff to the terminal, basically. The link should be in the chat window, basically, yeah. So I guess that's all the necessary stuff before we start. So briefly about Allas. So Allas is an object storage. And object storage is a modern way to kind of store data. All the big cloud providers have one, the Amazon S3, Microsoft has its Azure Data Lake, and well, we have Allas. So we use Allas for a storage service for all the computing and cloud services. It's meant for a CSC project's data during its lifetime. So it's not a place where you can store data until the end of the world, but to the basically the lifetime of your project. The default storage space you have is 10 terabytes per project. So it's already quite a lot for many projects, and it's possible to increase that even quite significantly. So don't be afraid of that limit either. Allas is storage system that it's easily available from Puhti supercomputer, and also in the future, near future, the Mahti supercomputer, and also from your personal laptops or phones or tablets, or basically anything that can use these two protocols that Allas supports. And one good thing about Allas is also that the data can be shared via internet. So like I shared these slides with you, you can make custom URLs and share the data to anyone you wish. Okay, and how to get access? Really briefly, you can find better guidelines on how to get access and everything from the CSC documentation, but here's it really briefly. You need to register to CSC in mycsc.fi. You need a project. Either you set up one or you join already an existing one. You apply for Allas service. You need some billing units. And after you've gotten those, you are ready to use your 10 terabytes of storage space. You can also add other users to your project, maybe co-workers. And one thing that I could mention here is that if you have data in Allas, all your project's users have access to it, basically. So it's not user per user, it's always per project. So if you have some kind of data that you don't want to show to your coworkers that are in your project, then you have to do some extra steps. I mentioned those two protocols, so S3 and Swift, and I will be talking a lot about these two, and they're pretty they should be understood pretty well to actually know what you're doing with Allas. So they have some differences, but basically they just handle data management and downloading, uploading, creating, deleting functions. And let's say that S3, for instance, is used by some tools and programs like S3 command lines, rclone, and this one graphical user interface for Windows users called WinSCP. And Swift, on the other hand, is used by Swift tools, rclone again, A tools that are custom built, easy to use commands made by CSC, and CyberDuck. And CyberDuck is again a graphical user interface, which is possible to install to Windows or a Mac. The main key difference between these is the authentication. So S3 protocol uses permanent keys. Okay, it's nice and easy, but it's of course also less secure, as if someone gets access to your keys, they basically have access to your project's data. Of course, if your CSC username and password are already compromised, it's the same thing. With Swift, on the other hand, it uses these temporary tokens that last for 8 hours. So of course it's more secure as it requires authentication every 8 hours. And this can be a bit problematic with long batch jobs in Puhti, for instance. And also the metadata of individual files is handled in a slightly different ways between these two. And especially if the files are over 5 gigabits, it starts to be a problem. So the different protocols split the file into smaller parts, and they do it differently. So we highly do not recommend cross-using these two protocols. So it's not a good idea to upload something using S3 and download something using Swift and do it over and over again. You should maybe choose in your project which protocol all of the users should use and use that one. With smaller files, it might not present any problems, but if your file starts to be gigabyte sized, problems might arise. And the authenticating in Allas, it happens via this Allas conf command, which uses your CSC username and password and then receives the tokens and keys from Allas and stores them in Puhti to environmental variables, or if it's S3, it stores them in this config file. And after you've ran this Allas conf, the tools and programs know how to access Allas. The S3, like I said, stores those permanent keys in this .s3 config file, and you can retrieve them there later on as well. If you want to use these command line tools like allasconf from some other computer than Puhti, these examples here today are in Puhti supercomputer, and more precisely, it's login node. If you want to use these, you have to populate the correct environmental variables in your computer, so the tools know how to find your, let's say, the permanent keys for the S3. It's not difficult at all to do manually either. You can also basically install the allasconf command locally. It's shared in GitHub in the following address, and there's guides how to install it. So about the tools, there's really many tools that you can use with Allas. We maybe recommend rclone the most, or at least today we're talking about rclone the most. It's kind of like a straightforward power user tool with a lot of features, and it's fast and effective and available for all operating systems. One thing to remember with it is that it overwrites the files without asking. So if you're downloading something again, it will overwrite them without asking. The rclone default by default uses Swift, but also S3, and those permanent keys can be used. And again, all of these details can be found in docs.csc.fi. The link is in the slides. Here are some graphical user interfaces as well. So if you've used graphical ones or use graphical ones rather than command line tools, the WinSCP is maybe the best option, as we know that it's usually possible to install by IT departments in various institutes or universities or so on. Let's say you don't have admin rights and you can't install programs as you wish. Other one is CyberDuck. It's free as well for Windows and Mac. And also FileZilla, but you need the Pro license. So the free one won't do the job. There's some experimental graphical user interfaces, like actually rclone has one nowadays. We haven't tested it yet at all, but we'll test it later. It might be useful. Then also this POTA csc.fi, you can list your buckets there, your Allas buckets and files, and you can even use it for uploading single files or deleting single files. But it's not meant to be as a kind of all-around web interface. Rumors tell that maybe CSC will have a good and efficient web interface for Allas in the future. Maybe not in the near future though. Also, one thing I've heard is that it's actually nowadays possible to mount Allas or Allas buckets with rclone, so you can actually access them from your Windows Explorer. So a few words about GDAL. So GDAL is a geographic software. It's usually behind all other softwares. So let's say QGIS, different Python libraries, R libraries, they all in the end use GDAL. And GDAL is mostly used with reading and writing files. So it's kind of this file format, file management software or library. And it actually supports Allas to some extent. So this is kind of geospatial stuff related to Allas. So it supports reading data, for instance, via S3 and Swift protocols, and also just with HTTPS. And if GDAL supports something and it works, then all the other libraries that use GDAL support it too. So we will be using a few Python and R libraries today, and they work with Allas mainly because GDAL works with Allas. But it isn't possible to write directly to Allas with GDAL. And so mainly with GDAL, it's about writing locally to your computer and then copying it to Allas. With R and Python, you can also write to memory, like a temporary file, and then write that one to Allas. And we'll come back to this later. And also one thing we will be coming back to is these virtual rasters. So if you have a lot of data and you want to store it in Allas, you don't have to copy it all the time to Puhti. And you can keep it in Allas and use only this virtual raster in Puhti, which makes it really efficient and easy to use. So I have some examples and exercises. We had some minor technical difficulties, and I was supposed to show these slides at the same time as I'm doing the commands in the terminal. But for some reason today it's not an option. So I'll go a bit further with these slides or exercises, and then I'll switch to terminal and type these commands basically. You can follow this as well if you have access to Puhti. Just log in to Puhti from Puhti or some other SSH program, and you can run these commands as well. Yeah, but you can also follow just what I do. It's up to you. First of all, we're now at Puhti, basically on a login node, clean login node, haven't done anything. We load this Geoconda environment because it includes GDAL. And here's some examples how to just print out some information about a file in Allas. And this time we are actually using the HTTPS protocol, so just over the internet basically. And how we achieve that is we just add this /VSI curl / and then the address. So the /VSI curl is actually a driver that GDAL recognizes, and it knows that, okay, this file isn't locally, we can find it through this driver and this address. And this driver we're gonna change it a bit, so it's a different one for S3 and Swift. I'll use it in a moment. And we can also, with this VSI curl driver, we can run GDAL commands like normally over the internet, basically, to Allas. And this last one, this GDAL translate, basically copies that file to Puhti. The same thing for S3. This time we have to run allasconf. And when you run it with S3, you need to write this mode S3 CMD. And it prints out the access key and secret key. And after that, you're good to go on Puhti. So this time we use a driver called VSI S3, but it works the same. And the same thing for GDAL translate. And with Swift protocol, again, it's the same thing except minor differences, like with Swift, we have to export some environmental variables, like you can see with the export Swift auth token and so on. And the driver is called VSI Swift. Maybe I'll now show you quickly those commands. Now you should be able to see my terminal. So I'm in Puhti login node. I have to look a bit what I'm doing actually. So first of all, we need to load Gioconda. Then we have GDAL at our disposal. I have too many windows here. Just a sec. We can run GDAL info. This was over the internet. So we used VSI curl and then the address, and we get all the information about that file. And the GDAL translate, I'll copy paste it here. It looks like this. GDAL translate, VSI curl, and the same. Actually, we need a bit more. Okay, let's call it local file here in Puhti. And that's it. I won't be maybe demonstrating the other ones, as they are basically the same with only minor differences. And also, it's not a good idea for me to run Allas conf with S3 as it prints out the keys. So if we're recording this webinar, it might not be a good idea to show my keys to everyone, as they are permanent. Okay, one thing more, that if you want to like copy paste code from these slides, which is awful, I know, you can use the same example data as well. So one slide further, I didn't show it to you yet, but if you make these folders, so webinar results, and then swirly character means home, so your home folder, and that, you can make that folder, and then with copying the files there, you can just copy paste the rest of the code I have, and it should work. I won't do it because I've already done it. I think I'll switch to the PowerPoint again. All right. So let's start with Python. I'll go through these exercises again, and then I'll type them in the terminal later on, and show you how it's done actually and what it looks like. So if you're using Python and you want to use Allas, this section kind of works as well for people that are not from GIS background. The files are some geospatial files, but the methods are basically universal. So with Python, we want to use mainly maybe, or if we want to use S3, then we need to load the Allas module, run the Allas conf again. If you've run it once, you don't have to do it again. Then we need this Gioconda, which is the environment where we have Python. And I do these exercises in just Python console for demonstrating purposes. You probably have scripts or you run them with some IDE in Puhti. first we have only a few libraries. OS is just for like file paths and stuff. Boto3 again, on the other hand, is the library we use with Python and S3. It's basically a library that uses the Amazon S3. I had some static folder or file paths. You should change your username here if you want to follow this. And I have a bucket already made called webinar. And this is basically the magic part, or that part. So you create an S3 client with Boto3. If you haven't yet created the bucket you want to use, you can create it with ease. If you haven't created a bucket and you try to upload something there, it won't work. You have to have a bucket, at least with Python. And with Python, it's basically looping files and uploading and downloading them. So for those a bit unfamiliar with Python, we just loop file names in our folder where we have these TIFF files. It's the example data I was talking about. I'll show it you in a minute. We create the full file paths and then just upload the file. We tell it that, hey, upload this file, upload it to this bucket, and the file name we want it to be in Allas is results/file name. And this results here is one of those pseudo folders I was talking about. So as I mentioned, that Allas only has one level of hierarchy. There's only buckets and files inside buckets. So you can't have kind of traditional subfolders like endlessly. But you can fake that you have those with just basically naming your files like this. So this could be like results/a/file name, and it would represent a pseudo folder structure of results and A. It's usable if you want to divide your stuff inside your bucket to smaller sections. For just listing your stuff in a bucket, again, we just loop the objects in a bucket and print out the keys, which represent the names. And you can download them back like this. For the GIS people or those purposes, you can also save files directly to Allas without actually saving them to Puhti first. So for instance, in rasterio, if you have some raster data, here we have, again, one of those files we'll be using. We just read it to rasterio. We read actually what's inside of that file. Then with this memory file, we write the results or that file to memory first and then upload that to Allas. This kind of saves maybe a few lines of code, or if it's a really big file, it might save some time as well. But you could also save the file locally to Puhti and later on move it to Allas. But the memory file, I guess nothing fancy here. We create a memory file, we open it, we write the contents of that raster we opened inside, and then we upload it, the memory file, to the bucket. Okay. I have no idea what it looks like to you when I'm switching windows here like a maniac, but now I'm switching. Just a sec. Okay. that's the correct terminal. Soon you should be able to see a terminal again. Okay. Now I have a bit better setup with my windows. Okay, let's start with Python. So we need Allas, we need Geoconda modules. I already have them loaded from the previous exercise. So I can just start a Python console. Okay, then we'll import those libraries. I'll copy paste a folder which has those example files I was talking about. I think I didn't actually show them to you. We have a bucket called webinar, that's just its name. And then we can initialize the client. The Allas endpoint is a3s.fi, if you're wondering. And then we could upload all the files we have to that bucket. I'm copy pasting code from PowerPoint, so we already know that probably, or can guess that it won't work unless I do the indentation myself. So 4 spaces. Oh God. Maybe better to start again. So basically with Python, you have to loop every time all the files if you want to use upload or download to multiple files. With R, there's some better options nowadays, and I'll show them you after this Python. Okay, it takes a while, and now we have uploaded all the files from this results folder to this bucket. Let's see what there is in that bucket now. Okay, so these are our files. There's 7 of them, and they are inside a bucket, but they have this one pseudo folder called results. We can download them back. Again, looping them quickly. And getting an error. What could it be? No such file. It would be impossible to have a presentation without a demo effect. Well, I won't check what's the deal with that. It's probably something to do with my file paths. But for the rasterio part, we can do that. So import rasterio library. And from rasterio, we import memory file. Okay. So now we have a rasterio object from that TIFF file. Let's read what's inside of it. And now we're ready to save it to Allas as a memory file. There's a bit different ways of writing those file paths. If you use pseudo folders, you have to write them pretty often everywhere. But it's maybe a best practice to have one bucket for kind of one type of data. So treat buckets as folders maybe. You can have 1,000 buckets in your project, and you can have 500,000 files or objects in your bucket. Okay, well, that uploaded them, or the one file called from Python. Maybe we'll actually can print out again the contents of that bucket. And we see the previous ones, and we also see the from Python we actually just uploaded. That's the part with Python now. We can exit Python with quit and move out to R. For R, I will show you the slides again. All right. So with R, there is currently 2 different environments for R in Puhti. The kind of old one, or for many of you, the current one is called renv. And the new one, which is, I don't know, a week's old or maybe a month old, is this renv singularity. And the funny name comes from this kind of container system we use, and that is called singularity. So this R environment is running on a container, and it has plenty of good things that come with it. But it's a bit different than the old renv. So okay, our exercises are with S3. So you have to have ran allasconf mode S3 again, and you can start a login node R session with this singularity wrapper. With compute nodes, like from a batch script, it's a bit different, but you can look into that documentation. The library is called AVS S3. Here's some directories again. We call our bucket and list the stuff that is inside. And the AVS S3 has this pretty nice S3 sync function or tool. So it knows how to synchronize your folders. Let's say you have a directory and you want all the stuff from that directory to a bucket, and the other way around. You can do it with this. This is, though, only available in Puhti in this renv singularity version, which is the new one, as it has the newer AVS S3 library, and this feature is, I believe, quite new. So basically, you can synchronize stuff, and you can tell it, do you want to download or upload it, and also you can traditionally loop the files and delete them, or also loop them and download them, or loop them and upload them. If you're using the older R environment still, it had that older AVS S3 library, and it kind of requires looping files. The synchronization function, I think, exists there, but it's not as good as in the new one. And also, if you have a script, R script, let's say, and you create like a new raster file, calculate a new raster file, and that's your output, you can also save it directly to Allas with this S3 write using function. And it's kind of like a function that lets you use other libraries functions, like in this case, the raster libraries write raster function. If you use the newer environment, the singularity environment, you have to kind of, I'll go a bit backwards, you have to kind of spam that region equals nothing, basically, empty string parameter everywhere as the library kind of thinks that you want to use Amazon S3. And well, we don't. That's a way to write rasters directly to Allas from memory. And I think I'm a bit late on the schedule as I have to move between these desktops, but I'll just let you see this WinSCP slide still. So WinSCP was this graphical user interface, which is probably the one that you can install by your IT department to your computer the most easily. This is just an example how to set up the client for Allas. You have to have that access key and secret key, and you get those either from the file that allasconf writes, or then you can copy paste them from the print out that the command does. So when you write allasconf mode S3, it prints out those two keys. And you just input them there and change the port and host name, and you're good to go. So I'll maybe actually skip the R part. It's pretty much copy pasting lines. But one key to remember or take home with you is that the synchronization function is pretty good. Another GIS related stuff or command I was talking about earlier is this VRT, so virtual rasters, which is a GDAL kind of file format, and it's really usable if you have large quantities of data in Allas. If you have, let's say, aerial images of whole Finland in Allas, but you're interested in some parts and another time some parts, so you don't want to actually interfere with the whole data set all the time. And you don't really care in which file that data is. You can use these virtual rasters. So you can create it. The virtual raster is a file. So it's this VRT file. It's basically a list, or it's an XML file that has a list of all those individual, let's say, aerial images. And you can treat it like it was a single image or single file. This I think I could, I have time to present. I'll again switch to terminal. All right. We are here. Let's see what we have. We have a folder called webinar. In it, we have results. And there's our files. So if we want to make a virtual raster out of these 7 files, well, first of all, we have to actually run allasconf as that rclone command, which we have next. It uses Swift and not S3, or at least I couldn't get it to work with S3. So let's just quickly authenticate with Swift. Swift doesn't print anything, any secrets or anything, so it's pretty decent. Okay, now we have 8 hours of token. I'll again copy paste. All right, so this rclone ls, so it lists something. It lists all files that end with TIFF, and it tries to find those from a bucket called webinar and a pseudo folder called results. And that list, it will print to a text file called file list. All right, we have a file list now. Let's see what it has eaten. Okay, now we have only the file names, what were in that bucket. Well, that won't yet do. The next command, which looks frightening, just basically goes through all the lines in that file list and adds this file path in it to every file. So we get the full file path in Allas. And again, you can see we have this driver here, which kind of tells us that, hey, this is Allas and not our local computer. If we check the file, we see that, okay, we got all those file paths again. And now we can actually just create the virtual raster. We create it with GDAL, so GDAL build VRT. We give it the file list, and the output is now DEMS VRT, so digital elevation models. And we can find it here. If we look at it, it's an XML file, not that pretty, but here we can see it kind of has information of all the files. What are their extent, what is their resolution, blah, blah, blah. So it knows everything about those rasters, and through that it can kind of look it as one file. So now we can treat that as a single image, which is really handy. If you would have like thousands or tens of thousands of rasters, and you would make them as one virtual raster. So this command, I have these in the slides, clips a part of that virtual raster. So this is a really small part somewhere near Åland, I guess. I randomly chose the files, and it creates a new DEM out of those. So remember that these files are now located in Allas, not Puhti, and the DEMS virtual raster is just kind of referencing them. And it's done. We have a clipped DEM TIFF now. And the tests we have made for if you have a data set that's really the whole Finland, so it's huge, and you want to clip something, this is reasonably fast. It's of course slower than compared to if you would have the data in Puhti, like locally. But of course, as you probably know, you can't have huge amounts of data locally on Puhti. But it works like this from Allas as well, so you don't always have to copy the stuff from Allas. You can use it straight ahead. And especially this VRT is really useful. Okay, that was the virtual raster part. And I think I'm pretty well in schedule. Here's some links. Basically, just more reading, more studying. We have some, or basically these examples and a lot more about GDAL and virtual rasters. They can be found from research.csc.fi. We have code for Python and R. They are in our training GitHub, which is open for everyone. You can find it from those links, and the general CSC documentation I was referencing quite a lot. It's docs csc.fi, and nowadays there is documentation for also Puhti, but also Allas and Pouta and Rahti and pretty much all CSC computing platforms or data storage. That's pretty much it for this presentation. Now I'll try to find out our chat window and hopefully maybe see some questions. So if you have any questions, now's a good time. All right. Okay. Yeah, I can start with the questions. I managed to find them. Does the keys are permanent mean that even if needed, it is difficult to change them? I think you can change them with the allasconf command pretty easily.
Actually, I tested it, didn't change them. You have
Yeah,
to figure
but
out
you
that.
need maybe some extra parameter.
Maybe, yeah.
We can also find out that and maybe even document it somewhere. But the details I don't know actually, but I believe they are changeable because that would make the most sense. Can we create the bucket inside Python, or must the bucket be created outside? Yeah, you can create it with Python and the Boto3 library. In the slides and the code, there's actually a line where you create the bucket. I had already created it, so I didn't recreated it. Can this all be done from ePouta machine? Yes, but you would have to install the software, the command line tools, for instance, there yourself or whoever is managing that machine. But in essence, yes, certainly.
Is the question about ePouta or cPouta? Because
ePouta.
But ePouta is not, maybe doesn't see that well outside.
Oh, the network. Yeah. Now that you said it, it's true. I think they can open ports to Allas for sure, but it depends on the projects like security details and network details that is it possible. Out of the box, I believe that ePouta is completely kind of enclosed, so you can't probably see Allas from ePouta by default. But I know that ePouta is possible to open to some extent the network. From cPouta machine, then it's just a case of installing the software and opening the port yourself. Can you use Allas with GeoServer or some other geodatabase system? Allas is, the one kind of property of Allas is that the data inside it is immutable. So you can't like live change it. The data always has to be moved somewhere else from Allas to do something to it, basically, and then moved back. It's like a safe. So GeoServer or some other database can't be hosted or stored in Allas. You can, of course, let's say, back up a database to Allas. If you like back up it to a single file and store it in Allas, that's a good way of doing it. But to run a GeoServer or something that uses data from Allas, I don't think it's very.
I can comment that a little bit. There is a extra plugin for GeoServer to supports reading raster data from Allas kind of object storage. That is one option, but I think it's not really widely used. And the other option is that GeoServer cache can be for the APIs can be stored also to object storage. But Allas is not a computer in that sense. You need to install the GeoServer in any case to some other, to cPoda, for example, or Rahti. But you can save some of the data there, but it's not enough for many cases.
And of course, it's always slower if you use Allas. The connections between CSC services like Allas and Puhti are fast. Like they probably couldn't be a lot faster, but still, of course, there's latency and if the network is crowded or something, it can even vary a bit. So it always takes more time if you store stuff in Allas and access it directly. One question is there difference between Allas and the more conventional disks, mostly capacity? I would say that the difference is quite substantial in other ways as well. The kind of why Allas is what it is, or why all object storages are what they are, is that they're really scalable. Because they operate with these buckets and objects, it's the kind of management is a lot easier, and the scalability is a lot better than in more traditional disks. And the difference, like I said, is that there isn't any hierarchy in the data structure except at one level in Allas, and of course a lot more other differences as well, and the tools are completely different. So there's some learning to do if you want to use Allas or the other big object storages. But if you find something that works, let's say for the Amazon object storage, it probably works for Allas as well. If you just can configure the endpoint in some way. The product basically is pretty much the same, to my understanding. Is there any other questions? Oh, okay. So if you're storing data in Allas and you would like to view them, well, Puhti mostly works with command line tools. There are options to have graphical ones. So let's say you can actually start QGIS, for instance, from Puhti, and you can correct me if I'm wrong, Kylli, you can let's say view those virtual rasters. So the files are in Allas and the QGIS running in Puhti or somewhere else, and you can access and view the files. But I don't have now any visualization for those images I used in the exercises. They were basically an Finnish National Land Survey digital elevation models.
As QGIS is also based on GDAL, then I think you can use the same virtual drivers as Johannes was explaining before. Then you can basically have QGIS in Puhti or QGIS in your local machine to open and visualize the files that are in Allas.
Yeah.
At least the public files you can for sure. The other ones I think we haven't tested, or maybe we. I think it was possible. I think I actually once tried to open over S3 also.
Yes. And all the tools and software related to object storages and Allas, as an example, are developing really quickly. as most of the companies and other businesses are transforming to these or transferring to these object storages from traditional storages. So there's a lot of tools that we haven't even tested and just noticed that, okay, this has a graphical user interface and so on. But I guess it's time, if there isn't any other questions, I think we could maybe wrap this up and yeah. There's links to the CSC YouTube channel this webinar will be hosted in, and also feedback form you can use to give feedback as well. So thank you for participating and see you soon.